Okay, hello, welcome to the channel. My name is Victor, and I will be your anchor for this series. So this is the CompTIA Security Plus exam preparation guide. Good enough, we're in lesson 13, analyze indicators of malicious activities. So here we're trying to look at indicators of compromise. And when you hear the word indicators of compromise, you want to see what are those things that indicate that there's a malicious activity? What are those things that indicate, oh, I think something is fishy here? So how do you get to know about that? So the objective for this module is that you should be able to analyze indicators of malicious activity in malware, physical, network, and application attacks. So let's first look at malware attack indicators. So what are those things that you see indicative that you have a malware attack? Now, don't forget the word malware. So malware is the umbrella word for anything that causes system malfunction. It's actually a compound word that means malicious software. So malicious software. So here we have malicious software classification, or just put it short, malware classification. So classification by vector, right? That's the attack vector, or infection method, how you can classify malware by how they actually infect the digital assets you have, whether it's your website, your network, your PCs, your devices. So how do you get to understand them? We can actually know them by classifying how they infection method. Now, viruses and worms. So these two spread within code without authorization. But of course, Trojan, a malicious program, concealed into a benign one. So something that doesn't look like, something that doesn't look too suspicious. It can be a software, it can be an application, it can be a file, but that file has something embedded into it. At times we talk about alternate data stream. You could check that up. So when you have two streams of data compressed into one. It can be a PDF file, it can be a software that looks like legitimate software, but it is not. So it has something in it that is going to cause malfunction. So you call that a Trojan. There we have potentially unwanted programs, that is the PUPs, then potentially unwanted applications. So at times, you see, there are some things that you don't really need that goes alongside some softwares. That's at times you're trying to install some softwares, and at times some of these softwares can look legitimate, but they are luring you to kind of get something along with it. So these can be potentially malicious. So we have pre-installed, that's bloatware, or installed alongside another app, or not completely concealed, but installation may be covered, right? You installing something and something is installing behind the scene on the background, and sometimes they can be called greyware. We can also classify by payload, as in what kind of action is attached to that particular malware. So for symbols, you have viruses and worms. You have Trojan, that's Trojan horse. Then you have PUPs. Now, computer viruses rely on some sort of host file or media delivery vector. So most of the time, they cannot spread without first getting hold of a particular system. So non-resident, memory resident, boot, at times script macro. Script macro most of the times for things like Excel or Microsoft-based tool or Office utility applications. So for the exam, you want to be able to differentiate the different types of malware. So if I were you, I will have a simple table that helps me classify the different types of malware. That's to say Trojan, spyware, adware, scareware. I've talked about Trojan horse, virus, and all of that. But most of the time, you see that we classify everything as virus. So they all differ in terms of how they propagate themselves or the kind of actions they have. Then we have early computer worms. Most of the time they propagate in memory or over the network links. So that's why we say the safest and the best, most protected digital asset is that asset that is in isolation. So if you have, let's say, a PC or a phone or a network or something, and it's completely isolated from any other device, that is the best and that is the most secure system ever. So, but when you start introducing pen drives, hard drive, just a moment ago in the office here, we had a system that had a malware infection. So we had to do a lot of things. We had to, even the installation, Windows 11 PC, even a fresh installation did not work. We had to do a reset. Even doing a reset from the Windows utility didn't work. I think we had to do that through BIOS just a while ago, over like 2 days before we can fix that particular system. So at times, like for this, in this case, it happened from sharing a file over another phone, getting files from a phone through another PC. So I remember another instance where you have a network. I talked about isolation earlier on. So one of the ways you can fix such kind of issue is to isolate the system. So once system starts collecting files, start going to the internet, start downloading emails, of course, most of these things can spread. That's why you see here over network links or over shared devices. They also have fileless malware, exploiting remote execution and memory residence to deliver payloads. They may run from initial script or Trojan. At times, they can be persistent with the registry. I remember there's this Raila Odinga malware that I had that was very common sometime in 2008. Yes, about 16 years ago now. So that malware was very, I think I gave one of my PCs to somebody else. I had a HP, I think then a DV6, then maybe another Toshiba. I think I gave her the Toshiba system for somebody to use to do some things, for some research work. By the time I got the system back, this system had the Raila Odinga. I think Raila Odinga is one of the politicians somewhere in East Africa. So I think that malware is an adware. So I'm saying that it's a malware because it has malicious intent, but it's an adware. So how does it operate? In every 4-5 seconds or minutes, you have a banner that loads on your browser and it says vote Raila Odinga. So it was like a political campaign and it infected the system registry. And the funniest part is that most anti-malware couldn't get hold of that because there was no anti for it. I think it took me almost 3 days, nights, to be able to get a registry patch that was able to take that particular malware infestation from the registry, because that particular malware was persistent by the registry. So you cannot just, it's not as if it's holding on to a particular file or your Windows files or your Windows whatever. No, it's hooked onto the system registry. So we have use of shellcode to create backdoors and load additional tools. At times, backdoors can be used to maybe copy files from a system or do what we call data exfiltration. So data exfiltration is where data is being stolen without knowledge of the asset owner. Then we have living off the land, exploitation of built-in scripting tools. And of course, we have the concept of APTs, advanced persistent threads, advanced volatile threads, and low observable characteristics. I talked about just a while ago, spyware, adware, keylogger. So you're able to differentiate them. The differences between them is that for the spyware, what they do is to get screenshots from via the system camera. That's why you see some people, they cover up their camera or they turn up their camera or they disable their camera device. So you have spyware. Spyware will do something close to what, okay, that's a spyware. Then we have adware. What an adware is going to do is just going to run an advert. So at times, it might not be harmful in its sense, but it can be malicious in the sense that you spend a lot of time without interference. Like the case of the Raila Odinga, Imagine you just working on your PC and every 3 minutes you have your browser opens and it shows a picture of a political party and says vote that, vote that. So that kind of thing can be great loss to man hour. Then we have keyloggers. So keyloggers are going to log your keys. So they will log your keystrokes and that information is passed on. Okay. Then we have, I've talked about backdoors and remotes. So you have backdoor malware, remote access Trojan, bots and botnets, command and control, backdoors from misconfigurations, and unauthorized software. Imagine having an unauthorized software that you install, but that particular software is sending packets, is sending info to another IP. I think on the channel, I have a video that talked about some basic SOC tools. You can check out the sysinternals tool, the TCP/IP view. That particular tool is very nice because it can show you for every application that you have running, what packets they are sending out, where they are, what those IP addresses are, and it can help you to trace if there's something malicious with the particular tool you are running or what the tool can be running on the background. They will have rootkits. These ones, they affect the system firmwares. Local administrator versus system. So if you the principle of least privileges apply here. So you want to grant only limited access, because if somebody is an admin, that means he can install whatever. And if he has if he gets by a malware, that means that malware can also take up that privilege and affects the system. Then we have another class of malware, which we call ransomware, and very recently, crypto malware, and of course, logic bomb has been there all the while. So, but let me differentiate them. So you have ransomware. So anytime you see something like a mail telling you that, okay, we now have access. Okay, I think that there's a screenshot here. So we now have access to your files. You have to pay so and so amounts to Bitcoin. So the question is, why did they use Bitcoin? So they use Bitcoin because somehow it's going to take a lot to be able to trace who is behind that. So because if it's a regular bank account number, you can easily tie and say, okay, this is the person, this is the identity, because most of the times for you to open a bank account, you need to do KYC. So ransomware, anytime payment is asked for, ransom. So you call that a ransomware. So you have crypto malware, same thing, high impact ransomware, crypto mining, crypto jacking, hijack resources to mine cryptocurrency here. Because crypto mining takes a lot of processor speed, processor RAM, and all of that. You need supercomputers to be able to do mining. So what this category of malware is going to do is that there's going to be a hijack. You have a script, you have a software that is being passed on, and it can pick system resources, it can pick phone resources, that is processor speed, malware speed, bandwidth, and aggregate that at some end. So imagine you needing, let's say, 1 terabyte of space, or you needing 1 terabyte per second. You might not be able to have that from one infrastructure, but if that is gotten from 10,000 users, so from each user, you're just picking up a few kilobytes per second, and that can be achieved. So of course, logic bomb. So in the case of logic bomb, you have a situation whereby you have, maybe take for instance, if a web page, and that's why input validation is very important. You have a file, you have a form to be filled. The person puts in a name, phone number, this and that. So once the person uploads what the person is not supposed to upload, or a file the person is not supposed to upload, or far greater size of file that the person is supposed to upload, you call that a logic bomb. And the most malicious aspect of this is where that file is meant to exploit that particular system. So if the folder for upload is soutech.com/upload/file/ if the name of the file is abcd.exe. So once that file, if the person can trace the file path for all uploads and that file is uploaded, then that particular file can be run. So that's why it's good for developers to do a lot of validation across their websites, across their enterprise. There must be validation. Then you must have a lot of access control and permission, because not everybody can run any kind of file as a public user. So you want to reserve those privileges for just your authors. There we have TTPs, that's the tactics, techniques, and procedures. So you have most of these things properly documented on Mitra ATT and CK, that is a Mitra attack. So you can look at this documentation to see quite a lot of signature detection by antivirus. Most of the times they're ineffective. You can see some tactics, you can see some techniques, you can see some procedures, you can see some indicators of compromise in cloud, network, web, mobile, PCs, IoT devices. Now we have malicious activity indicators. So how do you know that you might have a malicious happening? Anytime you see your browser changes, or you have some kind of notification, or you see that your system is consuming a lot of resources, or you see that you cannot access something, you have blocked content, or you see that your account is compromised, or you cannot install software like the case we had in the office just a moment ago, or you see that some files are missing, these are indicators of compromise. Or you see that your system is very slow, all of these account to malicious activity indicators. Okay, so we've looked at how we can classify malware. We've looked at computer viruses. So we said that a malware is an umbrella word for everything, anything that causes system malfunction, and we can classify them as Trojan, spyware, adware, keyloggers, backdoors. So all of these are ways we can classify malwares. So let's look at indicators of compromise within our physical and network systems. So let's talk about brute force. So anytime you hear the word brute force, think about multiple attempts to get into something or to get access to something. So imagine if you are attempting to access a door and you hit so many times with different attempts, that can be likened to a brute force attack. So for a website, for a network, you're not attempting several passwords multiple times simultaneously to see if you can have access, right? So you hope you know RFID, that's radio frequency identification, and NFC. So we have cloning and skimming. So cloning in the sense that the data in that particular, the chip in that particular RFID card or NFC card is being cloned, and this can be used to access a particular system. That's why these items, badges, cards should not be left anyhow, even keys, because most of these things can be cloned and they can be an inroad for people to access your network. Network here, I mean, if people can have access to your building, of course, they can have access to your network. Then network attacks. So we have reconnaissance and credential harvesting. So, of course, these things happen at the very first stage of a hack. So there are 5 stages of hack. So we normally say reconnaissance and footprinting, scanning, gaining access, maintaining access, and clearing tracks. So for every hack to happen, it goes through these 5 stages. It doesn't happen like in the movies. There must be first reconnaissance and footprinting. Credentials have to first be explored. We need to know things like names, things like IP address, things like locations, things like the topology of the network. Those basic things have to be gotten first. Then before we talk about scanning, then we'll talk about gaining access. And in gaining access, what can be done? Denial of service, weaponization, delivery breach, executing application. All of these things are done during the stage of gaining access. And of course, other things that can be done to maintain access, which is the fourth stage, is command and control, beaconing, persistence, data exfiltration, then creating backdoors and trying to pick up information. Then at the last stage, which is clearing tracks, here, all of those things that might amount to an indicator of compromise, we don't want anybody to get to see that. So like I repeat again, the 5 stages: reconnaissance and footprinting, scanning, gaining access, maintaining access, clearing tracks. And that's why most of the times for every digital forensic that is going to be done, it starts with reconnaissance, and which is you trying to see the tracks that was not cleared. I don't know if I make sense. Now, you have 5 stages of an attack. The last being clearing tracks, the first being reconnaissance and footprinting. So anytime you're trying to do reconnaissance and footprinting, you're trying to check for the tracks that was not cleared, because there was a compromise, and that every compromise most of the times is going to leave some form of tracks, and that's what you do when you try to do reconnaissance and footprinting. So we have distributed denial of service. So you should be able to differentiate, for example, the difference between a denial of service and a distributed denial of service. So the clear difference there is just that for denial of service, enterprise services are denied just from one point. Whereas for distributed denial of service, there's leverage, there's quite a lot of hosts, there's a kind of a bot, a mirage of systems or IP address trying to do a particular task. It's just like saying if you have a banana and you have one monkey trying to pick that banana or trying to exploit that banana, that's a denial of service, right? You have a website being compromised from one threat actor so that people cannot access the website or people cannot log into the website. That's a simple denial of service. But if this is not happening from 300 PCs, 300 attackers, 300 items, like a botnet, trying to still do that one particular thing, you call that a distributed denial of service, because that denial of service is coming from several points. And one of the things that they might want to do is to overwhelm with superior bandwidth. There's a lot of bots, or consume resources with spoof session request. That's a sync flood. Imagine a normal three-way handshake is going to be a sync, right? A sync arc and rather a sync, yes, a sync arc and an arc. So you say, okay, I want to speak to you. Okay, yes, go ahead. What do you want to say? Then, okay, yes, okay, let us start conversing. So, but now you're just sending only a sync. So it creates a lot of confusion, and the other end gets confused, it gets overwhelmed, and it can lead to that system being down. And of course, the guys that are going to be trying to use that system, they are going to have a denial of service. So you have a reflected attack, you have an amplified attack, you also have the DDoS indicators. Okay, so this security onion trying to drop some top signatures. If you're taking the Cisco Cyber Security Operations Associate, it's on the channel too. The complete playlist for that course is available on the channel. The entire 28 modules is recorded. You could sign up for that course if you're interested. It goes a great in-depth into the security onion. There are 2 labs, the Cyber Ops Workstation and the Security Onion Workstation. You could check the channel and go through that particular series, or you could contact us and get signed up on the Cisco platform so that you can get that certification. And if you have questions so far, you can ask on the comment section or use the mentorship group on WhatsApp, and we'll answer your questions. So we have on path attack, track actors position between hosts. That's what we call man in the middle. Imagine you have communication between 2 lovebirds, a guy and a lady. So instead of there to be a very seamless communication between the two, you have somebody in between trying to eavesdrop, trying to hear what each other is saying. So that's what you call a man in the middle attack. and you have the ARP poisoning. You should understand first what is ARP. ARP is Address Resolution Protocol. That's the guy that works together with DHCP to assign IP addresses to everybody on the network and also resolve if there's an issue, right? So if you come on the network, the ARP guy is going to say, okay, do you have an IP address? Okay, DHCP, please. This guy doesn't have an IP address. Okay, let's give him one. So it checks its MAC table or CAM table, content addressable memory. It checks to see, okay, do I have a MAC address, do I have an IP address, which IP address is vacant from our pool? So it picks one, DHCP server assigns the IP address to that particular device, and you have an IP address. If there's an issue or there's a clash between two people sharing one IP address, the ARP, the Address Resolution Protocol, tries to resolve that and assigns a new IP address to you. Or if you restart your system and switch it on back again, it's going to now resolve and assign a new IP address to you. The problem there is when that table that contains the IP address mapped to the MAC address, layer 2, layer 3, once that particular table is poisoned, then the guy becomes, it goes comatose, right? So it's not able to differentiate which PC is going to do this, which PC is doing that, and that can lead to an attack. So we have for domain name server, so we have typo squatting, DDoS, hijacking, we have DNS poisoning. This is not too common because a lot of hosts have gone a step higher, but for learning purpose, understand that every host is going to have a server. That server is going to have an identifier, a name, and you call that name domain name server. So if you go to whois.com/whois and you put any website there, it's going to bring up some details. The details is going to include the domain name server, that name, right? That's what helps to map the website to an IP address and resolves it on the server. So when you have any of these, right, that attack is on the server. But like I said, a lot of host platforms, except you have very, very unsecured host systems, that's when you have some of these kind of things happen, right? So we have wireless attack. So you have, I've talked about evil twin. Then we also have wireless denial of service, when you have jamming and you have disassociation, and you have wireless replay and key recovery. Now, that's why for countermeasures, one of the things you want to do is to make sure that you use very strong passwords. The key length is quite long enough, and you make sure that it's encrypted. You have good access control systems. It will help you to prevent some of these attacks. So in classification, password attacks, so we have online password attacks, we have offline, we have brute force, we have dictionary. For dictionary here, we're saying that we have a table that contains quite a lot of password that we're going to try to use to try to attempt. Then we have password spraying. We also have credential replay attacks. Here we have Kerberos, NTLM. Then we have credential replay attack against host and application. We have the pass the hash and we have pass the ticket. So this is an explanation of how the process is for a domain controller and a client. So this will happen typically in a Windows-based system, right? That's why you have Kerberos NTLM. Then we have cryptographic attack. So cryptography in the sense that when you have weak keys, that's why now there are some algorithms that are not so much in use because of their keys are very weak. So you want to use more recent algorithms. You want to make sure that you also do layering. You have multi-tier protection on the transmission of data between your server, your client and your server, either is on your network or whether is across websites. Then we have classification for malicious code indicators. We have shell code, credential dumping, lateral movement. We have persistence. So this happens on most Windows PCs, these registry keys and schedule tags. Then for schedule tags, we're trying to say, okay, we have something that happens, like it looks like a cron job that happens at every interval, or we have a PowerShell code that tries to like pick up items, or we have something that tries to pick up credentials and dump them maybe in a particular folder or something. So here we've looked at physical attacks, we've looked at network attacks, we've looked at distributed denial of service, differentiated between denial of service and distributed denial of service. We looked at password and credential replay attacks. We looked at cryptography and malicious code indicators. So here we're trying to say, how are you sure? What do you see? And you say that you might have a malicious code. So lastly, let's look at application attack indicators. Here now, looking at the last layer, that's application. So we're trying to say, what are those indicators that we see that we say maybe our layer 7 have been tampered with? So attacks that target vulnerabilities in application code or architecture design. So here we have privilege escalation. So privilege escalation is one hack method. I mentioned a few others. I said privilege escalation, executing application, clearing tracks, password cracking. So these are different ways that a hack can occur. So for privilege escalation, it can be a vertical or it can be a horizontal privilege escalation. So when you hear the word vertical, horizontal privilege escalation, we're trying to say for vertical is a line like this, horizontal is a line like this. So for a horizontal privilege escalation, it means two users of the same level, admins. Somebody gets access as an admin and gets another access as another admin. Or somebody gets access as a user, gain access as another user. But for vertical privilege escalation, we're saying, okay, we come in as a user or as a guest, and we escalate privilege to become an admin. I remember an instance where we had a PC at work, and somehow the PC was given to somebody like, okay, I want to help you in your career. I don't use this system again, but it's been a long time I used it. I can't remember the password. Okay, take it, and you can use it for your studies. Now, that was a legitimate transfer of asset. But the thing now is that we don't have the password to that system. So the question is that how do you get access? So we're able to find a way via DOS, via CMD to escalate a guest account to, because if you're trying to use a guest account on that PC to let's say run some tools and whatever, you're not able to do that. So every operating system, especially when not fully updated, we always have a leeway. We always have a way through which admins, administrators, or even guest users or normal system users can actually escalate privilege. That's why you see operating systems will from time to time patch the operating system to prevent some of these types of attack. So we have replay attacks. So this is BF. I think there's a lab on this. We could try it out. Same thing with forgery attacks. This is forgery attacks 2. This is injection attacks. So this is SQL XSS. Now, you need to study the OWASP cheat sheet. It's a very, very well documented guideline for you to understand most of those OWASP top 10 items. So that's where you have XML, SQL injection, you have access control, especially when it comes to web application. It's going to give you guidelines of what to do, what not to do, how best to present your application, and what countermeasures you should explore if you are going to make sure that you don't have some of these attacks. Because, for instance, for all of these, for SQL XSS, for instance, you have, like this is select statement. Anytime you see the word select hash, star, we mean we're trying to say, okay, we want to pick everything from the database, right? We want to select all the records on this particular user. The name of the table is TBL user. where username is equals to empty or 1 is equal to 1 dash dash hash. So this is always going to be true. And if this is going to be true, it's going to pull out all of the information. So I'm going to have a series on the channel sometime maybe next month, if time permits me, on the OWASP top 10, because it's a very, very important document. There's no cybersecurity certification that you're going to take that you're not going to come in contact with the OWASP top 10, because when it comes to cloud, when it comes to web applications, it's a very, very crucial framework for you to get to understand. So we're going to pick basic applications, or we can even create and script our own basic applications and learn how we can explore the OWASP top 10. Okay, directory transversal. So at times when people create applications and people can easily go back. Imagine just right-clicking on a particular file, and you can clean up that directory and go behind. Let's say we have victim.4/this. And if I clear this now, do I have access to all of this? So this is where directory permission comes in. So if the site does not have proper permission being granted, people can actually transverse across the different directory, which is very, very bad. Okay, for URL analysis, so let's go through this. So you have URL for a trusted domain with a vulnerable script. Then you have the query, it goes to the upload.php, that's the page that processes the stuff. Then this is the percent encoding. Then this is the obfuscated, that is the malicious and the hidden domain hosting malicious script. You see, it's appended on it. So now in web programming, we have what we call the HTTP methods. So you have the TCP connection, you have the get when you're trying to retrieve something, you have the post when you're trying to update something, put when you have to update something. You can use it for updating something also. In summary, most of the times we talk about the CRUD, create, read, update, delete. That's why it's good to also have some basic, maybe PHP, ASP, Python, depending on the language, whichever. Be able to build some simple basic script is going to help you understand some of this concept, especially if you are doing, let's say, vulnerability assessment, or you're doing pen testing, or you're trying to check scripts to see where you might have issues. At times, I've seen hacked websites where we're trying to fix, and you see some of these things happening. You can be able to tell what is okay, what is not okay, what you're removing, especially when you're doing manual testing, or you are trying to look out for indicators of compromise within script. Okay, server logs are very, very, very crucial. I think I've talked about this earlier on. I think this looks like a Linux server. Yes. So in this case, for instance, you have for a server log most of the times is going to have time. It's going to have date and time. So it's going to have date and time. It's going to have the URL of what's happening and what actually happened. So that's why at times if you have an issue, you want to go check your logs. So you can have error log, you can have traffic log, you can have status codes, you can have HTTP headers. And one thing you could do if you are also creating your own application, or if you're in a team that is creating the application, make sure it's a good countermeasure. Make sure that the developers are setting up logging system. You want to log traffic. You want to log if you have error. So if the server experiences any error or whatever, you want to log it. You want to keep track of it, because if something happens, that's always where you come back to in order to fix your issues. Like now, if somebody have a challenge on the web application and they say, okay, please help us fix this, we have whatever, the first thing we do, we go to the server and check the logs, because the log gives us a good idea about what happened in the last 1 hour, 20 hours, 10 days, 5 days, and whatever. And once you can ask questions about what happened, when it happened, then you can map that to the errors you have and find the fix. So we've looked at application attacks, replay attacks, forgery attacks, injection attacks, URL analysis, and web server logs. Okay, thank you very much. This is lesson 13. I'm going to see you in lesson Sorry, this is lesson 13. Yes, I'm going to see you in lesson 14.